All right, let's dive into one of the most powerful and frankly, one of my favorite features in all of C#, generics. If you're tired of writing the same code over and over again and want to make it cleaner, safer, and way more reusable, you are in the right place. Let's get into it.
So, let me ask you a question. Have you ever been there? You write this perfect piece of logic, you're super proud of it, and then you immediately have to copy, paste, and change it just to handle a string instead of an integer, or a double instead of some custom object. Yeah, it's a super common problem, and it just leads to bloated, repetitive code.
But what if you didn't have to do that? I mean, what if you could write that logic just once and have it work perfectly and safely with any data type you could possibly throw at it? Well, that's exactly the promise we're going to explore today. To really get our heads around this, our source material gives us this perfect analogy, a multifunctional toolbox. Think about it. You don't have a separate box for your wrenches and another one for your screwdrivers, right? No, you have one awesome box that can hold and organize any tool. The box itself doesn't care what you put in it. It's just designed to be versatile and reusable from the get-go. And that's it, right there. That's the whole idea. In the world of C#, this incredibly adaptable do-anything toolbox has a name. It's called a generic. It's the framework that's built to hold all our different data types.
So here's the absolute key takeaway. Generics let us design our code with placeholders for types. We get to define the logic, the what it does, without having to lock ourselves into a specific data type like an int or a string right away. It's kind of like creating a flexible blueprint that can be used with wood or steel or whatever material you need later on.
Okay, theory is great and all, but seeing this stuff in action is where it really clicks. So let's move on and look at some real practical examples. It's time to actually put some tools in our new toolbox.
One of the most common places you're going to see and use generics is with collections. And the absolute classic example of this is the generic list T. Now just look at this. On the left, we're creating a list specifically for integers. We do that by writing list int. And on the right, we do the exact same thing, but for strings, with list string. The list logic itself, it's written only one time. We're just telling it what kind of tool we plan on putting inside. That T in list T is just a placeholder that we fill in when we're ready to use it. Simple, but so powerful.
But this power isn't just for collections. Oh no. We can also use generics to build these incredibly reusable methods that can perform an operation on pretty much any data type.
Let's take a look at the signature for a generic swap method. See that little T right after the method name? That is the secret sauce. It's a type parameter, and it's basically telling the compiler, hey, this method works with any type, and for now, we're just going to call that type T. This means the logic inside can swap two variables, and it doesn't matter if they're integers, strings, or, well, anything else. And this just shows the payoff perfectly. We call the exact same swap method to swap two integers, a and b, and then we use that very same method to swap two strings, x and y. It's one method handling multiple data types with zero code duplication. I mean, come on, that is just pure efficiency.
So we've seen generic collections and generic methods, but we can take this idea all the way to the top and build entire classes that are generic from the ground up. By defining the class itself as stack T, we're creating a whole blueprint that isn't tied down to one data type.
Its internal storage, its push and pop methods, the whole shebang is designed to work with whatever type T we decide on when we create an instance of it. And here's the result of that. We can create an int stack that only accepts integers and a string stack that only accepts strings. We get the amazing reusability of a single stack class, but we also get the compiler-enforced safety that stops us from, say, accidentally pushing a string onto our integer stack. It is truly the best of both worlds. So, we've seen the how, but let's really nail down the why. What are the big wins here that make generics just an absolutely essential part of modern C#?
It really boils down to three huge advantages. First, code reusability. You write stack T one time, and then you can use it for integers, strings, whatever. That slashes redundant code. Second, type safety, and this one is a game changer. The compiler becomes your best friend, catching type mistakes before your code ever runs. This not only prevents bugs, but also gives you a nice performance boost. And third, flexibility. Your code just becomes incredibly adaptive, ready to work with data types you haven't even thought of yet. So when you combine all these benefits, generics stop being just another language feature, and they become more like a core philosophy for writing really good code. They are your new power tool.
And I love how .NET Full Stack Dev, the author of our source material, puts it so perfectly. Using generics is akin to a multifunctional toolbox that accommodates various tools without compromise. That last part is so good, without compromise. It doesn't just hold the tools, it's designed to work perfectly with every single one.
So at the end of the day, generics are really about writing smarter, not harder. You've now got this powerful, incredibly versatile tool in your C# toolbox. So the only question left is, what are you going to build with it?